So Dr. Yu received his PhD in electronic engineering and computer science from MIT in 2012. He designed robots to improve people's life, has always been his career goal. He is currently the CTO of XYZ Robotics. Let's welcome Dr. Yu.
Yeah, thanks for the introduction. Um, yeah, so today's talk is about from lab to loading dock, and we will talk about some hard truths about deploying AI robots. So yeah, today I think I'm feeling the gap of I would say research to market gap. So today I hope some of the viewpoint can help you say one day you want to bring your research into real market and to deployment. Okay, so and maybe today I'll bring more questions than solutions. Hope that will help. Yeah, this is today's outline, just 3 points. First, introduce myself and the company, what we do, and then lessons learned, and some RoboGen, like this workshop-related technology. Okay, so myself, yeah, we work on manipulation like very early on. I started in 2013. So yeah, at that time, I would say we are more model-based. I work on pushing objects, insertion, and yeah, this is kind of the work that we done at that time. Yeah, we are very curious about the like a friction and pushing, like how real motion, like this is collect from real, and how does that compare to simulated motion? And then on the side, besides pushing blocks, yeah, we like to make something useful. So at that time, we participated in the Amazon picking challenge. Yeah, so in the challenge is like in Amazon, there are million types of items. So yeah, we need to have the robot be able to grab any almost unseen objects from the bin from one to the other. Yeah, this is the last year we participated for 3 years. The last year we won the first place for the stowing task. One thing to note that, yeah, here the robot is just picking up a towel, and in the background you see so many people cheering. So that's what won't happen if you just do that. And you can see here there are 7 PhD students, including Shuran. She is now professor at Stanford. So there's lots of effort to build this. And yeah, for XYZ, we want to make sure like we are able to scale and able to use software to let somebody with high school degree able to set up system like this. Yeah, as I said, yeah, one thing is I want to make sure the robot technology really bring value. And also after the PhD, I kind of yeah want to make sure the technology developed in lab able to benefit real life. Okay, maybe yeah. Here I showed what we done at that time. So this is the block that we are pushing, and we are trying to collect the ground truth. The key thing here is yeah, this automated collection, yeah, we have a reset mechanism. Yeah, so we are able to collect data with very quick speed. Yeah, definitely at that time, yeah, we found that after we just collect so many data and we find that the pushing, the friction inside manipulation is just uncertain. This is what happened when you push so many times. This is the trajectory of the center. Okay, so and then for the Amazon picking challenge, we are kind of the first neural network based robot manipulation. Yeah, in 2016. So yeah, this is probably very normal for the current pose estimation framework. Like with RGB, you use CNN to segment out the item. Okay, and then use point cloud and segmentation you are able to align it well, align with your model well, and then get a 60 pose. Yeah. So that's the work that we done. So overall, yeah, from my PhD to currently XYZ, yeah, first we prefer like real data. So yeah, as you can, like it's less sim to real gap. Or sometimes even we try to mock up the real warehouse, it's very, very hard to find all the skills, all kinds of items, and all kinds of arrangement. So yeah, we prefer real data because also you eventually you want to test with real data. So we spend the time and effort to collect them. And the performance boost for say accuracy. So far our experience is about 5 to 10 times more. Okay. So yeah, a lot of effort will be how to figure out ways to collect and label more. So one idea is self-supervision, like on the right-hand side in 2017, how to label this very well. So the idea is, yeah, so we just take this picture and then remove this item, and then we do the direct RGB comparison. Yeah, find out where it's different, and then we are able to get out the mask very well. Yeah, and then on the other side, so far we are more prefer the vision motion test, like separate them, not the end-to-end test. Yeah, like a very important thing is in industry we need reliability and able to engineer meaning able to test part of it, change part of it, and be able to modify it based on some input from say a warehouse management system, things like that. Okay. So yeah, for XYZ, overall, what we are doing is trying to make the perception and manipulation available to free human hands and really get jobs done. Okay, get jobs done is very crucial because yeah, many times many robot products actually created more jobs because we need to babysit the robot. But here we want to really make sure it's really automated and it can take care of itself. Yeah, we have offices globally. Right now, I would say the trend is like because the say Europe and the US has a higher labor cost, so using robots makes more sense there. And we have many big customers, and yeah, here is a comparison of like having person like this is very hard to reach. I have done that myself during testing, so very difficult. And here, this is after we deploy, the robot can reach very high, pretty heavy, no problem. Okay, so yeah, overall the technology, robot technology, we are pretty full stack. So from hand, eye, and also foot, like recently, like this is a moving platform that can move the robot. And also hardware plus software. We work on basically all of them. Yeah, we build our own 3D cameras. Why we do that is because, yeah, there's industrial environment, temperature change, and also the field of view we need to be able to customize. Yeah, and then the end of arm tooling. So far, for boxes, for many industrial objects, I would say suction cup is still more useful because it doesn't need to go to the side to find a seam to grab. Um, all right, and then yeah, SLAM technology, vision to detect boxes, and also the motion planning with very good optimization that consider collision avoidance. And then here is the stacking, like Tetris in real world, and it really has a meaningful value because the more you can put in it, then the less waste during the transportation. Yeah, definitely we have some digital twin to simulate robots in simulation so that it doesn't collide in real world. Yeah, so now I'm going to show you some video of our two product lines. One is the more manufacturing industrial. So here you see, basically we need to pick precisely and place precisely, although there's not many different parts, but yeah, you need to get it from a more or less clutter situation and pick it and place it very accurately. Okay. Roughly the summary is like for vision perception for manufacturing is as I say, need to be very precise. Although it's just same parts, instance learning, okay, but we need to achieve very high accuracy, okay, something like 1 millimeter, in order not to say scratch or damage the parts. And also the processing time is about 1 second or less. Okay, so sometimes actually same parts is not easier. Okay, so you can imagine for computer vision if you are trying to find local features like these holes, and it's very easy to confuse this hole like whether they are on the same parts or not. Yeah, so it's very confusing. Like compared to this, it's very easy to distinguish these parts. All right. And then on the other side is more on logistics. Logistics is more boxes type of items. So this is, I would say, very fun. I'm very proud of like here, it's not just picking. So many times it's the placing is important. Like here, you need to make sure it flat it down. Yes, in order to getting it here. And also there's things about not the barcode need to be facing up. Yeah, so here is the turning mechanism if the barcode is facing down. Okay, so here to do this, I think is something that you probably don't think about is the compliance on this robot hand. So when you do the toppling, actually you need to exert some force, or when you do the suction, you need to exert some force. If it's this tube is like very rigid, if it doesn't have the Z compliance, then the robot will stop. And I don't think it's very easy to sense the interaction or force at this high rate. All right. So yeah, but definitely with the new embody AI, I hope somebody can do something like this and also at this rate. I haven't seen that. And on the other hand, so later we found that the small item is actually very easy for a human. The real pain point is like the heavy, large boxes. Okay, so for these large back boxes, the human labor has trouble with them. Yeah, so yeah, these are like we are probably the very first supplier for these kind of scenario. Okay, so the vision perception for logistics, there's more variations. Like even just this box, you can see this strip is at different location. And sometimes like this strip can be recognized as the seam between the boxes. So that's very challenging. So it's more category level learning and but still need some precision. Yeah, imagine you want to stack these boxes like very neatly. You still need some precision like 5 to 10 millimeter. Okay. So things like these bags, yeah, some picky customer would really want to pick right at the center, so that it will go through some cutting machine, cut this bag out and then spread the powder inside. Okay, so next is about our lessons learned. Yeah, so in PhD, your paper needs some metrics. So that's for submitting your paper. And in real world, when you deploy, you need some metric too. So what customer wants, I call it services. So let's take a look at this video. Yeah, first, the speed is important. Here you can see every item placed on it is probably only take 1 or 2 seconds. That's very different from, say, in the Amazon picking challenge time. Each item took us 30 seconds, and we got first place in the world. So in the real world, this is very fast. Uh, and then versatility, you can look at different parcels, bags, and envelopes. All you need to handle at the same time. Reliability is, yeah, you need to work 24/7. Cost, important. I will expand on that later. And ease of use, safety. Yeah, you need basically all 6 constraints, yeah, when you design your robot product. Okay, so I'll expand each item. Speed, yeah, usually in the industry, we measure peak per hour or case, unit per hour. Yeah, if you want to match human speed is like a 300 to 1,000. Yeah, depends on how heavy it is. That means cycle time is 3 to 10 seconds. But the important thing more related to research is, yeah, you only have 1 to 2 seconds for vision and motion planning. Okay, so all of them need to be inside that budget. Yeah, sometimes people say work slower for 24 hours, but in reality, that's not useful because usually your robots is connect to some upstream and downstream. Yeah, usually the truck driver don't work 24 hours. Some upstream picker doesn't work 24 hours. Yeah, so most of them, unless today we have a fully automated warehouse, a fully automated truck driver, then this may be true. Okay, so in nowadays, still robot arms at human scale are still slower than professional workers. Like their speed, their agility is very good. So yeah, when you think about your robot product, you hope to gain some superhuman capabilities, say heavy lifting or able to fly, something that human cannot do. So versatility is like this: unseen objects, textures, weights, arrangement, mixed item. So yeah, many people always only think about AI perception could be a problem, like I did. But usually nowadays I found like hardware is usually has the harder problems. So yeah, imagine you need to have some end effector able to grab uh, this kind of item and also large and small. Yeah, if you think about humanoid, it's very general. I don't think so. So like this is the height of the unit tree. So how do you climb up there and then grab it? And these are all 20 kilogram boxes, and you need to work at this speed. Yeah, you need to think very hard on the hardware side. Yeah, reliability. Right now, our robots usually work like this 16 to 24 hours and need to have global support. Yeah, and many industrial stuff, yeah, you need temperature, humidity, waterproof. Yeah, so yeah, this is the main online. Yeah, so I feel yeah, robot as a career is like this. You need to support it very often. Yeah, some idea in the future, maybe the robot should be able to fix itself. Yeah, if you are really want to scale, and also AI to help, like the say ChatGPT kind of interface for the on-site person to help themselves. That's also possible. Yeah, so cost. This is very didn't talk about that in school or in conferences, but I think it should be inside the robot engineering. So yeah, this is not hard. Customer calculates the ROI. Say today they hire a person like 40K per year. If the factory works 2 shifts, that's good. And they want 2-year ROI. And the value of your robot is something like this. Okay. So when I graduated, I thought something cool robots can worth a lot, but actually there's a kind of a ceiling for that. So this is the value. It's not bad here, but you need to, with that income, you need to cover a lot of things. Hardware, software are what you can see, but sometimes maintenance is something that you don't see. Okay. So AI related stuff here, cost is your data collection or labeling, some training, whether it's one model fits all or it's per customer. And then testing, the GPU resources is more like edge type of NPU that you need to think about. And many people want like high-speed internet when deploying, but it's not usually not available on site. Like warehouses are very remote. I mean, human doesn't need internet to work on the boxes, so they don't do that. They don't have that. So, and ease of use, yeah, two kinds of people. Maybe I'll talk about deployment engineers. Yeah, if you do motion policy learning research, so I hope like if you produce some policy, it should be able to understand by the engineers and able to be modified by engineers. And that's because, yeah, on-site bad motion can cause very disastrous results, like destroying the boxes or some causing explosion. So hybrid, I hope someday is like you can hybrid it with a classic approach. So something like if it's a normal case, you use classic approach that's more easy to tune, and then only either maybe focus on the edge cases, you use the learning-based approach. All right, so yeah, one introduction is our XYZ Studio Max to fulfill that usability issue. So yeah, in our company, yeah, to debug or to R&D, yeah, we have our own simulator, like the left-hand side. And then on the right-hand side, you see this is what robot is thinking right now, or what it perceive right now. And then bottom here is the like more no-code, like visual flow-based programming. Yeah, and also we have that for the task planning and also for the vision, also a vision flow to do the processing, the segmentation, detection, and show the results here. Yeah, so this is the first one that as far as I know, this first one that integrate all the needed stuff, vision, motion, and tasks, even plus HMI, the human machine interaction, all in one software. Okay, so
Peter, we have 5 more minutes.
Yeah. Okay, no problem. Yeah, so yeah, maybe some lessons learned on the computer vision challenges. One thing that we recently keep on working is like this. So imagine you have some product like this in the container, because there's a different block of color. So say here, and it detected, like the normal box detector will say this is a box, and maybe this is another box. So that's very confusing. So we don't have perfect solution right now. We kind of overfit to certain types of objects. Okay. Yeah, some occlusion that may happen that's not real. Yeah, and if you work on these kind of object pose, and like some elongated or low solidity object is very challenging. Yeah, so this is what we face. So, okay, so back to the RoboGen idea. So yeah, here is like very what we face in the real customers, and yeah, because we want to do fast deployment. So at the beginning we will train, like collect on-site, collect the 6 faces of these objects, and then try to render and kind of say shake the container in order to make it not that organized. Yeah, this is similar things, and we have reoriented so that it can recognize different faces. Okay, so let's see. Yeah, one idea here is, yeah, I mentioned like we like uh, real data, so we need some ways to easier collect real data. So yeah, a self-testing, like things that can loop by itself, works. Will help you. Like here, this is the piece picking. So what happened is, after it done one round of pick and sort to different bin, and then in the end of the day, okay, it take out, and then the things dump back. Yeah, so then it can loop it every night. Okay, so that can help you collect a lot of data. Yeah, one thing we contributed to the community is, yeah, we have this industrial data set submitted to the BOP. This happening ICCV also in this week. Yeah, so lots of this kind of, like, this is very challenging, lots of occlusion, clutter, and shining. And you can see, like right now, like these are the people that trained a big giant model, and it took like very long time to evaluate it. So maybe this is valid, but the score is not as high as we want. All right, so yeah, this is probably the end of the talk. Yes, for simulator, yeah, we often use it to um, find bugs, find collision, and optimize runtime. Okay, I'll let the video play, and happy to take some questions.
Okay, any questions from audience? Yes.
Sorry, I cannot hear well.
Yeah, Rigon, maybe you need to repeat the
Stairs.
questions.
Who's running up to the podium?
Yeah, so hi, can you hear me?
Yes.
Okay, so my question is like, thanks for the like talk. So my question is like, how long does it take us from like a practical view, for custom when they changing the box size or to other product, and how long does it take for retraining and then implement for your robot?
Yeah, right now, say if it's all brown boxes, maybe like this, there's no retraining needed. Retraining needed is like what I show you, like usually a box with color, texture, and it has blocks, like color blocks. That one we cannot have zero shot. We probably need some training, and currently training is probably 7-8 hours, something like that. I mean, there's a fine-tuning way, which probably inside 1 hour, yeah, kind of like that level. By the way, but for the industrial objects, yeah, it's changing it. It's just changing the CAD model, and inside one minute, it can start running.
Okay, thank you.
Does that answer the question? Yeah.
I have a question.
Yes.
Okay, go
So
ahead.
I really like the slide of the ROI, and you showed that
Yeah.
there's some challenging data set you would want more people to look into, right? And thinking about
Yeah.
it from a buyer perspective, if there are any other like data company can facilitate such data, what is the cost you're willing to pay to improve your product?
I mean, that's the same as we also need to calculate our ROI. I would say we reduce that a lot. I mean, we built our own platform. We built our own label data because we started in 2018. There's no people do that. So we built our platform, and people labeling it are inside China, somewhere very remote. So we don't pay high costs for that. I don't feel there is another provider that can provide better service. At least right now for us, it's like that.
So instead of
Um,
buying, you prefer making it in-house. Okay, yeah, I saw some.
Yeah. Right now that's the case. Yeah, we also need to justify for our own ROI for labeling. Yeah.
Okay,
So have
let's thank our speaker again. So I think next we move to the panel session.
Yeah, Frank, you can ask your question in the panel.
Yeah,
Peter
yeah,
will be staying with
I can
us.
ask that later. Okay.
Yeah. Here are some contacts if you want to contact me. Yeah.